Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0717, signifies an issue with the input turbine speed sensor A, specifically indicating that there is no signal present in the circuit associated with this sensor. The input turbine speed sensor plays a crucial role in the operation of the continuously variable transmission, CVT, by monitoring turbine speed, which is essential for optimal transmission function. When this sensor cannot send its readings to the powertrain control module, PCM, it affects transmission operation, leading to shifted performance or even transmission failure. This error code is primarily triggered by electrical circuit problems rather than mechanical issues within the transmission system itself. As such, mechanics must focus on investigating wiring connections, sensor integrity, and electronic components rather than the transmission unit itself. Making a distinction between electrical and mechanical failures is vital in diagnosing the root cause of a problem. The input turbine speed sensor is an essential component of the CVT, located within or near the transmission housing, specifically around the torque converter area. Its primary function is to monitor the turbine speed and relay this information to the PCM, which then optimizes power delivery from the engine to the wheels. A failure in this sensor or its circuit prevents proper functioning of the transmission. This DTC P0717 is confirmed through a detailed electrical circuit inspection. As such, mechanical problems within the transmission will not trigger this code. Understanding the sensor's role and location can assist technicians in effectively isolating the issue's source. Given that the symptoms usually stem from electrical failures, thorough checks of wires and connections near this sensor are necessary. The primary cause for the appearance of DTC P0717 is an electrical circuit problem, rather than a fault in the transmission mechanism. This might be due to a malfunctioning input turbine speed sensor itself, which could be unable to transmit data due to internal failures. Additionally, loose or corroded connections between the sensor and the PCM can lead to intermittent failure of the data signals, mimicking the symptoms associated with the DTC. Another possible cause could involve damaged wiring related to the sensor, including shorts to ground or opens, which will necessitate detailed checks for continuity or voltage abnormalities. Recognizing these potential causes is crucial in enabling targeted troubleshooting. The symptoms one may experience when DTC P0717 activates primarily relate to the performance of the vehicle's transmission system. Users may notice the transmission may not shift as smoothly or may become unresponsive under specific driving conditions. There might also be warning lights illuminated on the dashboard, signaling an issue with the transmission. Inconsistent shifting patterns can emerge, causing unexpected RPM variations or engine strain due to improper gear selection. These symptoms stem from the failure to relay accurate turbine speed data to the PCM, which then disrupts the entire transmission operation. Understanding these symptoms can help vehicle owners recognize a potential problem before it escalates into a more significant issue. The first step in troubleshooting DTC P0717 involves verifying the problem is indeed present. First, turn the vehicle to on mode, but do not start the engine. Then, clear the stored DTC using the Honda Diagnostics System, HDS. After clearing, the vehicle should be turned off and securely lifted to allow the wheels to rotate freely. Once elevated, start the engine and disable the Vehicle Stability Assist by pressing the VSA off button. Subsequently, take the vehicle for a test drive, maintaining speeds over 19 miles per hour, 30 kilometers per hour, for at least 30 seconds. It is crucial to then check for any pending or confirmed DTCs via the HDS following the drive. If DTC P0717 is reflected, it confirms that the failure duplicated. If not, further inspection of connections may be warranted. For step 2, begin by turning the vehicle off to ensure safety during inspection. Following this, disconnect the torque converter turbine speed sensor 3P connector to isolate the sensor from the circuit. Next, turn the vehicle to on mode without starting the engine and proceed to measure the voltage between the identified test points. Specifically, you will be checking the voltage between test point 1, which is the torque converter turbine speed sensor connector, number 1, 2, and test point 2, which serves as the body ground. If a voltage of approximately 5 volts is detected, it confirms that the circuit is intact. If not, it indicates further issues that need to be explored. In step 3, the task involves ensuring the integrity of the VCC2 wire, which is a crucial component of the electrical system. Measure the voltage between test points 1 and 2 again, with the vehicle in on mode and the torque converter turbine speed sensor 3P connector still disconnected. Test point 1 corresponds to torque converter turbine speed sensor connector number 3, while test point 2 continues to be the body ground. If the result indicates approximately 5 volts, it reveals that the VCC2 wire is functioning correctly. If it does not meet this criteria, thorough inspections are necessary for the VCC2 wire that runs between the sensor and the PCM to identify any open circuits. For the 4th step, the mechanics will assess the torque converter turbine speed sensor. With the vehicle still in on mode and the 3P connector disconnected, again measure voltage between specific test points. In this case, test point 1 is torque converter turbine speed sensor connector number 1, and test point 2 remains as connector number 3. A reading of around 5 volts confirms that the sensor has power, indicating it may not be functioning properly. If the sensor fails this check, it should be replaced immediately. However, passing this test indicates the sensor might be operational, directing attention to reviewing connections related to SG2 wire instead. In troubleshooting step 5, the task involves identifying possible shorted wires within the circuit. Begin by turning the vehicle to the off mode and utilizing the HDS to jump the short circuit SCS line. This action will externalize any faults present in the circuit. The next step requires the disconnection of the PCM connector B, which is a 51-pin connector. Once disconnected, check for continuity between defined test points in the vehicle's wiring. Here, test point 1 is torque converter turbine speed sensor connector number 2, and test point 2 is the body ground. If continuity is confirmed, this indicates a short to ground exists within the NT wire, necessitating repair. If it is not showing continuity, it implies that the NT wire is intact. In the final troubleshooting step, an open wire check is performed specifically on the NT line. Ensure the vehicle is in off mode, maintaining the 3P connector disconnected as well as the PCM connector B also disconnected. Measure continuity between test points. Test point 1 is again torque converter turbine speed sensor connector number 2, while test point 2 is PCM connector B number 45. If continuity is confirmed, this indicates that the NT wire is functional. If this wire is operational, and if necessary software updates are available for the PCM, it should be updated or a known good PCM should be utilized. If the DTC P0717 ceases after this update or substitution, it suggests that the original PCM was at fault. Conversely, if continuity is not confirmed, repair any open circuits present in the NT wire between the sensor and the PCM. After completing the troubleshooting process for DTC P0717, it is essential to perform a final verification to ensure that all repairs were effective. Begin by clearing any DTCs stored in the system using the HDS. Once cleared, take the vehicle for another test drive to ensure that previous symptoms do not recur. Monitoring the vehicle's operation during this drive confirms that the transmission engages smoothly without any fault code surfacing. If no DTCs reappear and the vehicle demonstrates proper operational characteristics, it indicates successful troubleshooting and repair. This final verification is crucial to ensure customer satisfaction and vehicle reliability. To prevent future occurrences of DTC P0717, a proactive approach to maintenance is crucial. Regular inspections of the wiring and electrical connections related to the torque converter turbine speed sensor can help identify issues before they escalate. Additionally, periodic checks on the functionality of the sensor itself can catch any early signs of degradation or failure. It is also wise to stay current with any updates to the PCM software, as manufacturers often release improvements that can affect vehicle performance and fix underlying issues. Implementing these preventive measures ensures the longevity and reliability of the vehicle's transmission system, enhancing safety and driving enjoyment. In conclusion, DTC P0717 indicates an input turbine speed sensor A circuit issue that primarily involves electrical problems rather than mechanical failures. Mechanics should focus on assessing the circuit integrity, inspecting connections, and testing sensor functionality as part of troubleshooting. Understanding this DTC's implications is crucial to ensuring prompt and effective repairs. Also, implementing preventive measures can significantly reduce the likelihood of similar issues emerging in the future, ultimately leading to enhanced vehicle performance and reliability. By following the outlined steps and tips, technicians can effectively navigate the complexities of this trouble code and contribute to improved vehicle service quality. Please like and subscribe to the channel. See you next time.